Okay, we are continuing with June 2012 to 2013, sorry. This is again one of these problems that we see almost every region. They want to determine the sum and the product of the roots of a given quadratic. Now, you can see that that quadratic is probably a little hard to factor, although you could probably factor it, or a quadratic equation. But an easier way to do that is with the two formulas. The sum of your roots is negative b over a, and the product of your roots is c over a. It matches up to the formula for your quadratic equation. It's doing the opposite of when we break it down through the formula, we build it back up. So, pull these out. A is 12, B is 1, and C is negative 6. Remember to always show work. Even though you can spot it, make sure you show it. So we put in your sum, negative 1 over 12. There's your sum. We do your product, C over A, negative 6 over 12, and reduce this down to those terms. Here's a log equation, and we've been seeing your log equations pop up. Always remember that a log is an exponent. Follows the same rules. It's just the inverse. It's the inverse for an exponent. So set it up, log equals, line up those equal signs. The base of the log is the base of the exponent, of the exponential equation. So I'm going to use 27, here's my exponent, equals whatever's left on the other side. Now you can plug this piece right into your calculator, raise it to the 4/3. If you're going to use this, make sure you put this in parentheses if you don't have a fraction up there. This is going to become 81. It's actually the cube root of 27, which is 3, raised to the 4th power, which is 81. And then solve it like a regular equation. And then check and make sure that there's no extraneous roots, but we don't take the log of 0 or any negative numbers, and you'll be fine. Number 30, they're asking for the number of different possible arrangements. Arrangements normally tells us permutations. Different arrangements, because order matters. Now, the problem here is, if you interchange the S's, it still looks like the same word, even though I interchanged those S's. So we are actually looking for distinguishable permutations. In order to do that, you find out how many letters the word statistics has, which is 10. There's your 10 factorial. And how often things repeat. You have 3 S's, you have 3 T's, you have 2 I's. You take out the repetitions in the denominator. 3 factorial, 3 factorial, 2 factorial. Make sure when you put this in your calculator that these are in parentheses. And come up with your number. 50,400 different weights. Number 31, this is a problem using their cosine and your sine of your special right triangles. They want the product, and they want it in simplest radical form, which means this is exact value. So let's do the special triangle for 30 degrees. Even you can do it in your x-axis if it's even easier than your xy axis. Oops, not that way then if you're going to do a triangle. So here's your 30. Remember, opposite is 1, hypotenuse 2, radical 3. So your cosine of 30 is x over r, radical 3 over 2. And do your 45, same way. 1, 1, radical 2. And your sine of 45 is y over r, 1 over radical 2. Rationalize this to radical 2 over 2. Now, you can say cosine of 30, sine of 45, so this is our radical 3 over 2, times radical 2 over 2. Multiply the tops and multiply underneath your radical. Multiply the denominators. You cannot reduce under a radical and outside of that radical. So there is your lowest terms. But remember, that's the second time already we have seen your special right triangles. This is another nice one. This is another trig one. And we want to find the measure of an obtuse angle. Obtuse is between 90 and 180 degrees. So we know this is going to be in quadrant 2. We know this angle is going to terminate in quadrant 2. So we start with your equation. We divide by 5, and we get the cosecant of theta is 8 over 5. If you remember, it is the reciprocal of the sine, so therefore, the sine would be y over r. This would be r over y. So if you wanted to do this, there's your r over y. If it's easier, take the reciprocal here and the reciprocal here, and now you can put it in your calculator since they just want the angle to the nearest degree. You can find this to be 39 degrees to the nearest degree, but remember that's in quadrant 1, and that's the reference angle in quadrant 2. So in quadrant 2, you are 180 minus 39. So you're looking for an angle that's 141 degrees. Okay, number 33. This actually looks worse than it is. This is your composition, your function notation. This is g of x. So wherever we see an x, we're going to plug in a 10. So we're going to rewrite this to say a 10 square root 1 minus 10 squared. So we've got 10a. This is your negative 9. Now, your negative under a radical says take out the negative 1. So this is your 10a, square root of 9 is 3, times 3i. Work this out, 30ai, and then square it. So 900, a squared, I squared, and I, remember, is negative 1. So if I replace this with negative 1, remember you're multiplying negative 900 a squared. Here's another trig function, and it involves you knowing what your basic definitions are and reducing this down. It's an expression, so they want it in simplest form. In simplest form, they break down to sines and cosines. So break everything down to a sine and cosine. A cotangent is your reciprocal of tangent. So tangent of an angle is sine over cosine, y over x. So its cotangent is cosine over sine. the secant is the reciprocal of your cosine. So now we're going to replace those parts. So your cotangent, cosine over sine, times the sine. And put it over 1 if it helps. And your secant is 1 over cosine of x. So to reduce the numerator, we cancel out the common factor, and we're left with cosine over 1 over cosine. And remember your rules. Keep, change, and flip it over. And multiply. This will give you your cosine squared. And that's the only way to answer this. There's nothing to solve. It's just an expression.